the other guys will come in short. We are starting the next workshop with Dan Bogos, which will present Cdr Stats, carrier-grade rating engine with the use case of real-time charging for Kamailio. He started with the project a few years ago and is growing with Kamailio world along. So let's see what's new and how it can be used now with Kamailio for some practical stuff like, billing, getting money out of outside, Thank you, Dan, for coming. And
thank you for having me. So can you guys hear me? Does this work? Yes. Okay, perfect. Then, yeah. So a bit about our company background. We are located actually here in Germany. We have over 8 years of experience with server-side solutions in VoIP environment. We did platform implementations covering both wholesale and retail business categories. And we are really serious about real-time processing constraints and seriousness of live system outages. About the CG rates, CG rates is not, we keep repeating this because it's a very important part, and we do it on purpose. CG rates is not a complete billing system, and we don't want to be. And we have few reasons for that. We keep it as just a strict charging or billing engine. And the reasons would be that we want to be pluggable into existing billing infrastructures. Big carriers or operators are not really ready to give up their very expensive billing infrastructure in the favor of some new open source components. And in addition to that, it's way easier to integrate an engine together with some new services which can talk to your previous billing infrastructure. So we are ready to accommodate new components into service provider network, for example, adding a new VoIP switch or SMS service or a new data stream. And we keep ourselves non-intrusive, so we don't force the switch to talk to us, or we don't force the switch logic. We stay in the background and we just provide information. Whether the switch will use it or not, it's the responsibility of system administrator or the switch admin. We have a modular architecture. It's easy to enhance by rewriting specific components. We expose almost all the functionality via APIs. Even our components are talking between themselves via APIs. So we have for that JSON, we have JSON over HTTP, then we have some Golang specific GOB serialization. Then we are performance oriented. We have our own built-in transactional cache written by us. We support data aging, live counters, and so on. Then all our processing is asynchronous, and we do it via microthreads, so we are not limited by the so-called small number of threads. Then we are pretty feature-rich. We support, it's even hard to explain all in 1 hour how much we support, but basically would be multi-tenancy derived charging, which is becoming a pretty hunted feature. It's this queuing, unlimited queuing of resellers and distributors for the same call and so on. Then we have account bundles. We support combinations of different bundles, like minutes to various destinations, money bundles for some specific destinations, SMS bundles, data bundles, and all combination of also different types of balances. Then we try to be very agile in developing new features. So this is what we expect from our community, to always open new features. And we are a test-driven development project. We have in our test build approximately 9 tests. I think we are even more than that today. And this all 900 tests are run before we build a package or something. So I'm trying to keep it as digested as possible, because I want to focus in this workshop more on practical things. So I will come back on Friday on more details on theoretical part. But just that you have an overview, this is our subsystems implemented today and operational. And you can find here the classical rating, which has as main functionality to calculate costs for events. It's isolated from the rest of subsystems, and it's fully cache-driven, hence should be pretty performant. It's also referenced from other subsystems, for example, from accounting or from LCR. It's a standalone component. You just start it on a separate machine from the others. It should not matter. They all talk, as I told you, via RPC. So you can scale as much as you need the components. Then there would be the accounting subsystem, which has as functionality to maintain the accounts with balances. The differences between accounts and balances would be that each customer will get normally an account, and attached to that account he can get an unlimited number of balances. And you can do all sorts of tricks by queuing them or by prioritizing them and prioritizing them and so on. Then this accounting is the only subsystem which is only partially cache-driven, and that's for a reason, because we want to keep the accounts as safe as possible, and this is the reason we are saving them into a database, which in our case we need, due to speed, we use Redis. We support here async processing with account locking as well, so we are pretty thread safe. Then we have also in the accounting subsystem real-time fraud detection with automatic mitigation, and all these are done at the account level during balance operations, so it's in the lock stage. This makes it possible, actually makes it impossible to avoid it if you are doing balance operations, because the account will remain in lock stage if some actions are failing. Then we support all sorts of queued or scheduled operation on accounts. We have our own built-in scheduler, so we don't rely on things like cron or something. Everything goes through internal engine. Then the other subsystem would be the CDR server, which is a live CDR server. Its main functionality is, of course, to store CDRs from various sources. So it can be, the CDRs could come from us or could come from any other sources. It exposes more interfaces out, like HTTP, JSON RPC, or internal interfaces. Then it can rate the CDRs received using the other subsystem, the rating. Then it can also replicate, this is a pretty new feature, it can replicate the CDRs live. So you are sending one CDR to the system will calculate, will attach prices on it, and will return it in real time to you, to the server of your choice. So you can just post the CDR and expect it by the system posted when the CDR is ready, which is sometimes in milliseconds or less than milliseconds, and expect it in your other server already rated. So that server needs just to store the CDRs, has nothing to do with rated, because it will receive the already rated CDR. Then we provide, the CDR server will provide rated or raw CDRs to the Cdr Stats subsystem, which I will talk about a bit later. Then the LCR, again, a pretty new component which came naturally to us. Its main functionality is to compute real-time LCR. It's, again, very fast, being cache-driven. Depending on strategy used, will reference data from other parts. Again, about the LCR, I will talk more on Friday. Then history server, this was some sort of fun project to do. It's another standalone component. Again, most of these components you can run independent in your network from each other. So you don't need to use all of our components. You can just focus on one and run it in your network, because they can all be started as independent services. So the history server will archive rate changes using Git in human readable JSON format. So if you know how to send data to it, which can be via JSON RPC, you can get a nice formatted Git-driven history server. Then the Cdr Stats component, it's another important subsystem. It will calculate Cdr Stats in real time based on the data received from various sources. Again, it can be from our own sources, or you can push yourself to it. So the particularity of this is, again, it's very fast because it has nothing to do with disk. All the stats and queues will be held in memory. So you will be able to also configure unlimited number of stats for the same CDR. There are a lot of filters and rules which you can use on them. You just need to know your business rules. Then we support there also real-time fraud detection and mitigation with actions triggers, same like for accounting subsystem. Yeah, so this was just that you understand what's under the hood. And I will go now through step-by-step installation of CG rates, and also make it work with Kamailio, present you a bit about how they talk to each other and what's the logic behind the integration. This is a pretty new functionality. I think it's even something towards pioneering, because it relies on the very new and fresh module written by Daniel, the FAPI module, which is completely async. So I would love to get more people using it and help us making complete, if anything missing. So few words about the integration. There are more ways to integrate Kamailio with CG rates. And this depends on your traffic patterns. So for example, if you are a wholesale which runs a serious amount of call per second, and you are not really interested about very real-time CDR processing, which means if you are okay to receive 1 second delay for your CDR processing or something, then it should be fine to use it as CSV CDRs, because these CSVs are since always the most reliable CDRs you can get in a network, and the fastest to be written. Then if you want something like retail traffic with real-time prepaid accounts and real-time disconnects, then we propose to integrate it via the FAPI module, which will interact in real time with the billing engine and will be able to calculate timeouts, will be also able to execute recurrent debits on the same call and unleash the full functionality of CG rates. So yeah, via FAPI you can get all these 4 modes of billing which we support, which would be the prepaid, and the prepaid calls. What we consider prepaid are these calls which are really debited in real time, which means you can start more than one call from the same account, and you can get the functionality to really have them all switch off when your balance is debited. And we do this via the balance reservation mechanism. So we will query at regular intervals, as low as one every second. During your call, we will query the main account and we'll execute operations on it. And this, considered with a distributed architecture, you get the real-time prepaid. Then the pseudo prepaid is what many are keep trying to tell us that it's prepaid. This is some sort of emulation which sets during the call authorization phase, it will set the timeout of the call. And when the call will be finished, when the CDR will be written, they will deduct the balance and do the prepaid stuff. We call this pseudo prepaid because this mode is not able to work with multiple calls out of the same account. Then there is the postpaid, which will debit the balance at the end of the call out of CDR or event. And then there is rated, which is mostly to be used in like wholesale business where you don't care about keeping accounts or balances. You just care about rating your own CDRs. And regarding EVAPI, we have released a connector from Go. This is MPL, so anybody can use it and talk to Kamailio via that. From if any fans of Go language, you have a library for the EVAPI to talk to it. And you can do pretty much everything you want externally from Kamailio via this module. Then there is as I told you before, then there is the Cdr Csv processing, and in this, via this Cdr Csv, you can get 3 out of the 4 charging modes which we support, which is pseudo prepaid, postpaid, and rated. Regarding the real-time prepaid implementation, so what we will do is in call authorization, we will send an event to CG rates to authorize the call. And as a reply to this event, we will set the maximum call duration through dialog timeout. So even when your live debits will not pick up, you are still safe with the original dialog timeout timer. So in the case of call not being able to complete because of balance or other stuff, your call will be disconnected in call authorization phase. We are talking here about all this is in Kamailio asynchronous processing, so you don't have any more processes blocked until the billing will answer or until the database will react or something like this. Then in case of call disconnect, we will have the session manager component of CG rates raising an event towards Kamailio, and this event will be processed in event route module, and based on that, we will, based on another tip received from Daniel, we will be able to kill the call directly from the script. So, and again, this one is again asynchronous. Then when the call starts, so we pass the authorization phase. When the call starts, we will receive via event route, dialog start, an event into CG Rate Session Manager. And in that moment, we will start the debit loop in case of prepaid calls. And this can also mean that we will use derived charging. So out of a single call in Kamailio, we will be able to emulate unlimited based on your distributors or your resellers, emulate behind unlimited number of calls. Then on call stop, we will receive from Kamailio via event route dialog end or event route TM local request. We will receive another call stop event, and this event will stop the debit loops and will also write the CDRs if you want to. Now you can go also in a some sort of hybrid mode, like doing all this other than CDR, all the steps out of events, and process CDR still from CSV. So you get 100% security that you don't lose records, and you also get all the phases implemented. So then now we will get dirty and start installing stuff. What we will use for this workshop, it will be inside VirtualBox in my laptop. I will just have an empty Debian Jessie out of net install, so basic, no pre-installed other than ngrep and sudo, I think. And we will do Kamailio install out of Debian packages. It's just latest stable 4.2. And we will also have CGRates install. As pre-requirements are Git, Redis server, and MySQL server. Then the install we will do out of a nightly deb package we have built outside of this system, because all these features and Kamailio integration are pretty new also to us. So we wrote like last bits of code like yesterday or the day before yesterday. So we hope that we will be able in a couple of weeks to officially release RC6, and it will include the Kamailio support. So yeah, let's check about the installation. So, can you read?
I can read it, but I don't think it's...
Oh. Okay, now.
Zoom it a bit.
Colors. Okay. I can even try.
Yes, that's good.
Yeah? Okay. It's weird to me, but it's the price I need to pay for doing live stuff. So I have just selected here some comments to be at hand, because if you see, there is no Kamailio and there is no CGRates pre-installed, so no
safety net.
Yeah. So we take first the key of Kamailio, import it, then we add the Kamailio 4.2 in our apt sources, then we do an update and hope to have internet. And we install 3 different modules which we use for our specific workshop. So it will be Kamailio, Kamailio extra modules, and Kamailio JSON modules for the RPC JSON communication with CGRates. And now we just pray or sleep.
Pretty fast.
Yeah, so the biggest, of course, the most code is inside Kamailio, and yeah, it takes a bit, but we are almost there.
I know where you got the idea from this. It's because Emil did a live building of Jitsi video bridge.
Yeah, so I said, why not? If he got a prize, then I should try also live. No, but the last years I was talking a lot of theory, so I want this year to be really something for real.
I'll tell you what's good about this, because it's being recorded. People can go back and follow the video.
Yeah, and all these are inside a tutorial, so they can play it at home as well. Yeah, so now we will install Git, Redis server, and MySQL server, as I told you, as dependencies. Again, most of the things are, I think, MySQL related, which take time. But the full installation of all the dependencies and such should not take you longer than 5 minutes. Maybe 4. If you're lucky, then you can get in 4 to make it a dangerous demo. Yeah, so we are at, as password, we just put cgrates.org for a bit of marketing. It's just what we use in tutorials. So.
ORG, give it away for free?
Yeah. So we are almost done with MySQL. Redis should be faster to install than the big fat MySQL. We are thinking to get rid even of MySQL and use something like LevelDB with our own indexing on top, so to become even way faster than MySQL. People would say that MySQL is already faster, but we target speeds even faster than MySQL can do. So yeah, we are done. Now we get from a secret location the cgrates package. It's, okay. It was too secret even to me. So yeah, I think the package is like 70 megs or something. Should not be that bad. We got over the years quite some code inside. We have hit like 55,000 lines of code now, which in Golang it's pretty much a lot, because Go is, if you know Go, it's a bit compressed, and it's not like Java or so then, yeah, we got the package locally, then we just execute. Normally, if once we release it, it will be like apt-get install cgrates, and it should do like same like Kamailio. So you see, it's all installed now. Yeah, so we should now the next task after the installation should be the configuration. Then Kamailio, it's we offer already done Kamailio.cfg file, so you can get the idea what you need to modify in your own scripts. As I told you before, we don't want to intrude in your own logic, so all what we do between cgrates and Kamailio is we exchange data. Like we store things in pseudo variables, and whether you use it or not, it's your decision. And also because of that, it's your creation about what service you can reach, and when you want to call the billing engine and when you don't want, and so on. So yeah, in Kamailio, as I told you, we will provide a pre-configured CFG file, which you can get it out of our Git repository. Then MySQL will need to create the cgrates DB schema. And inside cgrates, we will need to configure some services to work with Kamailio. We'll look first on Kamailio configuration. When you install cgrates, these things are already inside the package. So we provide them as part of the demo tutorial, so they are already on your server after you install. So you don't need to extra go in another place and view them. So, for example, we should have them in share cgrates, and then tutorial, kam-evapi, Kamailio, etc, Kamailio, and Kamailio.cfg. So inside this, maybe I should go like that to see that. We found out that it's easier if we split the configuration into 2 different things and use includes inside the configuration. So you can keep inside your Kamailio.cfg just the nice part, and not the one which deals with the JSON and deserializing stuff, which tends to be a bit shocking at the beginning until you learn the semantics behind. So just to see what's in the Kamailio cgrates file and have an idea. So on new connection, we will just store it in a share variable, just to see that So we are able to detect that the connection is there or not. Because if the connection is, if we don't have a connection to CG rates, we don't want to allow the call to go through. So when the billing engine is sleeping, we don't want to be in the position that we get fraud or something. So this is why we are sharing the connection to be able to detect it. Then again, on connection closed, we clean it up from the shared memory. Now, this was very briefly done. We can go ahead and implement more connections and detect which one is what in order to clean up the shared variables. But for now, it was enough to us. So you can go and extend it if you want. Then we have done a special route on a special dispatcher route. So on message received, we will deserialize it from JSON, and we will dispatch it into its own route based on the event header. So with this, in this way, we were able to call different things in different routes, which you will see a bit more below. Then on dialog start, we call the CGR call start route, and on dialog end, we call CGR call end route. Then something which we learned later is that during local disconnects, we will not get this in dialog end routes, and we found a very valuable blog written by Daniel where he explained about the event route TM local request. So we are the ones reading this. Then in the out phase, we will just serialize things inside JSON format, and we will use things which we have previously set as dialog variables, so they can be maintained and be written also in the CDR end. And also we add some like TR index and TR label in order to be able to disconnect later and reference this request from outside. Then in the reply, this is the reply coming from CG rates. We will, this is the as I told you, a bit ugly written part, which we need to move away information which comes from JSON variable inside various other variables, which we will use outside of this encrypted config. Then you can see after we are done with processing what it comes in auth reply, we will send out a normal, much nicer looking request in another, resurrecting the transaction in a separate route outside of this, which you will see in the main file. Then in case of disconnect, again coming from CG rates, we will again deserialize the things, and you can see here the exec which is able to directly kill the call from inside the script. Again, some tip we learned from Daniel. Then CGR, in case of call start, this is the information which we send out. So we can start the sessions inside the prepaid controller. And in case of call end, again, the information which we send out. It looks a bit, ugly, but this gives you a lot of power, because this is like you writing your own code inside Kamailio and generating and processing events. So this makes you quite some powerful person. Now we go back to what is in the main file. So in the Kamailio CFG, you will just see normal things like here, for example, we didn't use any database, so we are just registering our users inside memory, so we can register from outside. We don't use a database for it because it's just for the sake of the demo here today. Then, the thing which you will see is some AVPs or dialog variables being set before sending the request to be authorized by CGRates. So you will see that we set the account. Here is just an example from username. And we set the destination, and we set the request type, which we use a switch. But again, this logic can be your own logic, how you define and which account is prepaid. And so all you need is to populate the dialog variables which we expect, like CGR account, if you use multi-tenancy, CGR tenant, and CGR destination. How you provision this is your own decision. Then we call the CGRates auth request, which was defined in the other file. And as soon as auth request is done, asynchronously it will call the CGRates auth reply, which is again something to understand. So in case of we have an error, then we log it and disconnect the call with 503. Then if we have a max session time defined, so we enforce it and set it via dialog set timeout. And if we cannot do that for some reason, then we again disconnect the call with error. So the call should not make it through if we have if we don't want to allow it, or if the billing system do not allow it. But if you don't write this logic and you write your own one, CGRates will not care unless it's a prepaid call, and for the prepaid calls, CGRates will send disconnect calls from out. Then if we have also configured the LCR functionality here. If CGRates is pushing us some supplier list, we will use the first supplier which was received, which in the end is just a tag, so you can follow it up and bind it to something like LCR module inside Kamailio. So by using this approach, you will give more functionality to the static LCR which you already have inside Kamailio. So you can have monetary functions or QoS functions inside the LCR module of Kamailio. Then, the rest, that was all about what integration you need to do. Now, a quick overview of CGRates configuration. So we keep our configuration inside, of course, like JSON. We do everything in JSON. And particular to this is that you can split under the folder which you start with, you can split into unlimited number of JSON files or subfolders. So you will see that we have some, actually we can have quite some templates for imports and exports, and you can organize them based on many things. So you can split the config again into how many you want. So this is our, these are all our default configuration, but I want just to show you what we did other than defaults, which are the uncommented things. So first would be starting the rater, then sending the Cdr stats, and actually from rater interrogating the Cdr stats, and this is done for the LCR purposes. Then we start the internal scheduler, so we can do actions scheduled. Then we will also start the live Cdr server. And of course, this Cdr server will send CDRs it receives also to the stats component, again, internally within the process. But we could also write here an IP address if we want to do it over the network, so if we want to expand over different hosts. Then we enable the Cdr Stats functionality. I told you standalone. Then we can have a default export template. Here you can, I hope I'm able to demo you. You can extend this list of fields as much as you want and use various fields for different customers. For example, the same CDRs you want to send to your customer, to your reseller, to your supplier, and for each you can use different formats and different fields inside. Then you will have the CDRC functionality, which is here not enabled. And you can see we have enabled the session manager for Kamailio, and it will also write CDRs. And you can see we have here one connection. The session manager can also handle more Kamailio servers. I don't know when there will be a need for that, but it can connect to multiple Kamailio servers and talk to them simultaneously. It knows things like connection ID and so on. Then the history server will be enabled just if we want to see the history archiving, the rates of archiving, and the history agent sending the information to history server. So yeah, this is all about the configurations which you need to do. Then one thing we need first regarding MySQL is to go and create the database schema. So this is located into, again, on your file system. So you go to MySQL and just run a setup. So you provide here your root, MySQL root, user, and password. So the setup script will take care about all the schema installation for you. And it reports you that everything was successfully set up. So we are done with configuration. Then we hit now the stage when we need to configure our tariff plan. So we again ship some pre-configured things because you can see quite some files here. But the reason, there are strong reasons to have so many files is due to the functionality we provide behind, all the filters, all the count creation, derived charging, LCR rules, and so on. So all you can configure inside these CSV files. If you want, you can also do it everything via APIs. So you do things from your own web interface and call APIs. So you don't need to use just the CSVs. So we go now to the place where we provide this. It's to tariff plans and tutorial. You can find them here if you just want to have a look inside. So rating profiles would be where you attach your rating profiles to your rating subjects. So this is how it will look like. So in editing CSV will never be fun. So we use, for example, things like Excel or Google Docs and export them directly from there. And the files are all referencing each other. So if you will look here, the rating plan ID, it will be, for example, for this any subject will be RP Retail 1. So in order to find out what's in RP Retail 1, we will need to open another file, which is rating plans. And we will have entries in RP Retail 1. And inside RP Retail 1, we will find destination rates tag and timing tag and so on. So you go from one file to another via definitions. Again, this is with all these were designed with specific things in mind in order to be as granular as possible and feature-rich as possible. Then how we load them? First, we need to start CG rates and Kamailio, so we will do that now. The command is already on your file system, so we just hit start, and now Kamailio was started instantly. Then we start also CG rates via same init script. It doesn't show much, but via the console, you can query its status and you can see it's up. If we want, we can check what's in our cache. And we see that we have nothing inside CG rates. And this is our purpose. Now we will load the tariff plans inside CG rates. And this is, we do it via a binary we provide, CG rates, CGR loader, and also verbose, so you can see what's going on. As soon as we hit enter, all the files inside this, all the CSV files will be processed and they will be bounded and sanitized together and so on. So yeah, you can see here that the rates were low. Now, if we look again in the cache stats, see that we have 4 destinations, 3 rating plans, 8 rating profiles, 4 LCR profiles, and so on. Then, yeah, regarding Sol, it's the best friend because it has, I don't know, if you want, it has a help. So these are all the commands which you can use inside the console, which are quite some. Then it provides history, and also it provides auto-completion. If you do so if you just type R and tab, it will choose things for you, or A and do more things and whatever. So all you need, it's inside there. Then, yeah, let's try to do some calls and see how Kamailio exchanges information with Cdr. So we have set up some prepaid users and, yeah, postpaid, also pseudo prepaid users and rated. And we will use for our test calls Jitsi. And you can see here we have enabled the accounts in there. So first, we make sure we go offline, and we register them all inside Kamailio. Now, what I will do, so you can see the exchange of information. So I will do now a prepaid call from account number 1001, calling account number 1002. You can see that it rings, and I will show you that behind are happening things. So you can see an auth request from Kamailio going to Cdr, and Cdr will authorize the reply and set a maximum session time of 6,000 seconds, and also provide the LCR for this call in the supplier list. And this supplier list, you get it only if you set here as variable compute LCR. If you don't need LCR, you don't set that var, and you will not get suppliers back. You can see a call start.
It's going based on cost right now.
It's based on cost. Actually,
Or other metrics right now.
no, right now not. Actually, they are, but not for this call. And so we stop the call, and you can see we get from Kamailio CDR call end, and we will write the CDR for it. Now, if you see, the previous max session time was of 6,052. If we are lucky and prepaid worked, then at the next call we should have less time. And in theory, we should have less with 60 seconds because we have configured 60 seconds billing for this call. So yeah, we should have like 5,000 something, 900 something. Let's see, I didn't check, so 5,692. So yeah, maybe it's something in the rating there. But the idea is that prepaid works, and all the things behind are properly communicating. Then I do a call end. The call disconnected again, and since my time is almost running out, I just want to show you how a CDR exports. So now we had debits, we have the CDR inside the system. Now we need to get it out. And for that, we will need to execute a command. So that should be, actually, in theory, we should just run a CDR export without an export template. I hope it works. So CDR, Kamevap API, Cdr CDR-E. And you see that one CDR was written there. And you see also the CDRs for our previous calls. And you also can see why we had that much debited, because also we had a derived session out of original one. So you can see the original are marked as default, and we have a derived one because, for example, we had a reseller or whatever, and out of original call, we had one more, which was, it looks like even more costly. So 9 seconds before, same 9 seconds duration here, just more money to be charged. So yeah, I think I'm almost off time, right? No, it's okay. Yeah, okay, then checking the Cdr stats quickly. Again, I have some command for that via the console. So how we do that? We can see the pre-configured, this all is defined in the CSV files which I loaded. So if you see here how many stats queues I had, these are all I wanted to use. And I'm particularly interested about 1001 because I was calling from that. And based on the filters you set in each, you decide what goes in each stat. Then let's grab the stats for the the 1001 account. And you can see that we have an average call cost for its calls of 0.3, average call duration of 29 seconds, and an ASR of 100. And if we want to see also the stats for supplier, because we had some calls to supplier 2, I hope they were calculated. You can see also quality stats here. So actually, these were also quality, but you see other metrics. So you can see total call cost and also total call duration. So this shows you that in each queue, you can decide what metrics are calculated and which CDRs are getting in which queue and so on. So exporting, I showed you. We can extend the template. As I told you, we can define which how you want to present when you export the CSV out. And also one particular thing I want to show you regarding the call log. It should be, I don't know by heart. So cost details. I don't remember all the parameters, so I'll put cost details. And it will, so cost details and CGR ID. Then I want to see why was my call charged in that way. So I use the CGR ID from the top. And I will get a nicely formatted reason for that. So then your support team can dig into all this and see why we charge what. You can also see how a balance looks like. And because it will help you to see, sorry, it was non-interactive mode. So this is an account. So you can see we have debited from here some money and also from here some seconds because they were originally in other. You can see that they have some special tariffs when you eat out of this and so on. So you can go deeper into all these things later. I would say these were fraud mitigation and so on. Yeah. I'm out of time, but I cover quite some stuff. So if you have any questions, I don't know.
Questions for now?
We see the call around 2 seconds, but there are available milliseconds of compression.
Yeah, you can use, I think, even nanoseconds. We didn't try it because we didn't have the test bed for it. But in theory, we support calculations Go supported nanoseconds, so we will be interested to find some CDRs with even milliseconds. Sure.
One of the really interesting things we want to do is to pre-rate calls, so find out how much a call is going to cost before you actually make it.
Yeah, so we provide that in via we have a cost simulator, and you can see, for example, here I have my exactly the same call I did, but with other time start and time end, and you can see how much this call will cost in advance. So you can see this cost, you can put it in, and you see it's incredibly fast because it all comes from cache, from RAM. And also why it will be calculated like that.
Time of day kind of considerations? When you mean pre-rate, during your question.
Yeah. Yes.
Like if you rated it on a weekend or at a different rate.
And also, yeah, that's one way of doing it. Also, the cost may depend on where the endpoints are. So if you're on VoIP, it will cost you one tariff. If you're on GSM, it'll cost you a different rate. And it depends where the endpoint that you are calling, whether he's on VoIP or GSM.
Yeah, we support that through category defining. So you can define when endpoint is there, use this rating plan. When endpoint is in another place, use another one.
Okay.
Quantity limits, like if I hit my limit for the 24-hour period or for the weekend.
Yeah, yeah. You do this.
Carrier data.
Yeah, we even go more than that. You can have quantity limit per call. So you can tell, I want my call not to cost more than €5. As soon as your call hits the €5, you can decide whether to disconnect or being free afterwards.
You know what I mean? If the contract with the carrier is I can do 2,000 minutes per hour, if I go over that, I want to stop.
Yeah, this is the balances. Is in the balance, and you can define the time frame when your balance can be used.
Okay, thank you, Dan.
Thank you also.
And for other questions,
Thank you. Thank you.